So we are continuing factoring trinomials. Everybody loves factoring. Now, what's different about today's lesson? So far, most of the ones that we factored, there's been no number in front of the x squared term, or we say that the coefficient of x squared is 1. Some of the ones that we've looked at, there was a number in front of the x squared, so that number in front was something other than 1, but we could take it out as a common factor. We're going to look now at ones where there's a number in front of the x squared and you cannot take it out as a common factor. Okay, so that's what we're looking at today. So you can see we're factoring trinomials of the form ax squared plus bx plus c, where a doesn't equal 1. It's going to be something different. Like the first one, the number in front of the x squared is 3. But there is no common factor, Keaton. Put that away, please. There is no common factor of 3 that we can take out. All right? So we need to factor this. Now remember, factors are things that multiply together to get what you start with. And just like we've done before, when you factor a trinomial, if there are factors, they will be binomial factors. So that's where we're going to start. We'll put down a double set of brackets. And the front terms in these brackets have to multiply together to get 3x squared because that's the first term in the trinomial. Our only option here is one of them has to have a 3x, the other has to be an x. It will not work with a 3x squared in the first bracket and just a 1 in the second bracket. You'll need x's in both brackets so that when you multiply it out, you get what you start with. Okay, now the last terms in the binomials have to multiply together to get the plus 4. So you've got a couple options here, right? You could have 4 and 1, a 4 in the first bracket, a 1 in the second. Or you could have a 1 in the first bracket and a 4 in the second. If you multiply them out, both of these, you'll get a different middle term. We need to get a middle term of positive 8x, okay? Or there could be 2's in each bracket. You can get 4, the last term of the trinomial, by going 4 times 1 or 1 times 4, or 2 times 2. Now, this is where we have to do our checking. This is like a guess and check method of finding the factors. We still call it factoring by inspection. You're inspecting the trinomial and you're trying to figure out what the factors are. So, in this case here, they multiply to get a positive 4, so that means both of the numbers have to be positive. And when you multiply out the binomials, those outer and inner products will give you an answer of positive 8x. So they both have to be positive, and to multiply together to get a positive value and add to get a positive value. So this is a little bit different than we did the last couple of days. It won't work if you find two numbers that just multiply together to get the 4 and add to get the 8. It doesn't work that way because the first term here is a 3x. So again, what you need to do is think of all the different possibilities, which I have written down now, and now we're actually going to multiply to check. Okay, the 3x times the x will give us the 3x squared. No matter which pair of numbers we use at the end, they're all going to multiply together to get 4. There's only going to be one correct answer for these, and so now we have to check each of these possibilities to see which of them gives us a middle term of positive 8x. So let's look at a positive 4 and a positive 1. Let's see what happens when we multiply the outer and inner products. The outer products would be a 3x times the 1, which is 3x. The inner products would be 4 times x, which is 4x. 3x and 4x give us 7x, not 8x. Again, the outer products would be the 3x times the 1, which is 3x. The inner products would be the 4 times the x, which is 4x. 3x and 4x add together to give us 7x, not 8x. So we can cross those ones off. They don't work. What if we did a 1 in the first and a 4 in the second? Again, they both need to be positive. The outer products would be the 3x times the 4, that's 12x. The inner products would be 1 times x, which is 1x. 12x and 1x add to get 13x, not 8x. So that doesn't work either. So the only thing that could work is the plus 2 and the plus 2. So let's check that. If you multiply the 3x times the 2, that'll give you 6x. The inner products, the 2 times the x, gives us 2x. 6x plus 2x is 8x. So there are our factors. The first factor will be the 3x plus 2, and the second would be x plus 2. There's the factors. And what we've been doing is we've been checking by multiplying. So let's do that. Let's actually check these. So here's our check. Using distributive property will be 3x bracket x plus 2, and then positive 2 bracket x plus 2. 3x times x is our 3x squared. 3x times 2 is our positive 6x. 2 times x is positive 2x, and 2 times 2 is 4. So you've got the right first term, the 3x squared. You got the right last term, the plus 4. When you add 6x and 2x together, that gives you your 8x in the middle. So we have just shown that the factors are correct. We've just shown that. Okay? You should never get these wrong because you can always check by multiplying them out. All right, so let's look at question 2. Notice there is a number in front of the x squared. Can't get rid of it because there is no common factor of 2. So if factors exist, they will be binomial factors. And the front terms have to multiply together to get 2x squared, which means you need a 2x in one bracket and an x in the other. Again, it will not work if you put a 2x squared in the first bracket and a plus 1 in the other bracket. You will not work. So these last two numbers are numbers that will multiply together to get 15. And you could have a 3 and a 5, a 3 in the first bracket, a 5 in the second, a 5 in the first bracket, a 3 in the second, because that will change the middle term when you multiply it out. Or you could also have 1 and a 15, a 1 in one bracket, a 15 in the other. Normally when we're doing our guessing and checking, we start with the numbers that are closer together, which means maybe I'll try the 5 in the first bracket and the 3 in the second, and if that doesn't work, a 3 in the first and the 5 in the second. They multiply to get a positive 15, so that means their signs have to be the same, and they're going to add to get a positive 11. That would mean that both of them would have to be positive. And now we're going to check to see which of these guesses works. If we start with the ones on the bottom here, the 3 in the first bracket, the 5 in the second, when you multiply the outer terms, 2x times 5 is 10x, and then multiply the inner terms, 3 times x is 3x. 10x and 3x do not add to get 11x, they add to get 13x. So that doesn't work. So what if we did the plus 5 in the first bracket and the 3 in the second? So the outer products would be 6x. The inner products would be 5 times x, which is 5x. 6x and 5x does equal 11x. So it appears that our factors are 2x plus 5 and x plus 3. And we can check to make sure that they work using the distributive property. We always do our check. 2x times x is 2x squared. 2x times 3 is our positive 6x. 5 times x is positive 5x. And 5 times 3 is 15. Again, you've got your 2x squared as the first term. You've got your 15 as the last term. When you add 6x and 5x together, you get the middle term of 11x. So we have just shown that our factors are correct. They work. So you should never get these wrong. Right? Some of you handed in those assignments last week, and some of you got some wrong because you weren't checking them. Okay? If you want to get them right, check them to make sure. All right, question 3. There is no common factor there. There's that 6 in front of the a squared. We cannot take it out as a common factor. So once again, if there are factors, they will be binomial factors. The first two that we did, there was really only one option for what multiplied together to get that front term. But in this case, there's a couple options that you could use to multiply together to get 6a squared. It can be 2a and 3a or 6a and 1a. Normally, I'll start with the ones that are closest together. But if I can't make those work, then I'll try 6a and 1a. Those are the different combinations that I'll multiply to get 6a squared. And the last numbers have to multiply together to get -2. So now, one of them's got to be positive, one of them's got to be negative. Okay? So you could have a 1 in the first bracket and a 2 in the second bracket. And you might think, well, I could also have a 2 in the first bracket and a 1 in the second bracket. However, you wouldn't get a 2 in the first bracket, and here's the reason why. We're checking to see if the first term is 2a. You would not have a 2 also in that bracket as the second term, because if you did, there would be a common factor of 2 between those two terms. If this first term is 2a and the second term is 2, there's a common factor of 2 among them. And that would mean that there's a common factor of 2, but if there was, there would have been a common factor of 2 in the original polynomial, and there's not. So that's how we know there would not be a 2 with the 2a. There won't be. So we don't have to check that possibility. However, you could have a +1 and a -2, or you could have a -1 and a +2. Those will give you a different inside term when you multiply them out by changing those signs. Again, they have to have different signs because they multiply to get a -2, which means one of them has to be positive, one of them has to be negative. So we're going to see if we can make this work, and if we can't, then we'll go to the 6a in the first term and a in the second term as a possibility. But we'll check this one first. So if we check the first one where it's a +1 in the first bracket and a -2 in the second. So the outer products will be 2a times -2, which is -4a. The inner products will be 1 times 3a, which is +3a. The -4a plus 3a gives us a -1a, and that's not right because we need a +1a in the middle, not a negative. Again, the outer product would be -4a, the inner +3a. -4a plus 3a is -1a, and that is not right. We need a +1a. So those don't work. You can cross them off. So now let's check if it is 2a times +2 and -1 times +3a. 2a times 2 is 4a, -1 times 3a is -3a, 4a take away 3a does equal +1a. So it appears that those are the factors, 2a minus 1 and 3a plus 2. Those appear to be the factors. And to make sure, we will check. We will multiply these out using distributive property. That's what we've always done to check. So the front terms, 2a times 3a is 6a squared. 2a times 2 is positive 4a, negative 1 times 3a, and negative 1 times 2. So I've got the 6a squared that I needed at the start. I've got the minus 2 at the end that I needed. 4a take away 3a is positive 1a, so it checks. It checks. So we've just shown that our factors are correct. They actually do multiply out to get what we started with. Okay? Question 4. There's a number in front of the x squared, a positive 4. You cannot take it out as a common factor. So again, if there are factors, they will be binomial factors. And the front terms have to multiply to get 4x squared. So it can either be a 2x and a 2x or a 4x and a 1x. Those are the things that would multiply together to get 4x squared. Now the last terms have to multiply to get negative 6. So it can either be a 2 and a 3 multiplied together or a 1 and a 6. We can say right now that the 2 and 3 won't work. And here's why. If you put a 2 in the first bracket and a 3 in the second bracket, the problem with this is that there would be a common factor of 2 in that first bracket. And if there was a common factor of 2, it would have been in the original polynomial. And it wouldn't matter if we changed them around. If we put the 3 in the first bracket and the 2 in the second bracket, it's the same thing. You've got both terms in the second bracket that have a 2 in them, which means there's a common factor of 2 there. If there was, there would have been a common factor of 2 in the original polynomial, which there isn't. So what this tells us then is that the 2x and the 2x won't work. It has to be 4x and 1x. And again, the last numbers multiply together to get negative 6, which either it can be 2 times 3 or 1 times 6. Now we're going to try the 2 times 3 first, but we would put the 3 with the 4. You won't have a 2 with the 4 because that would mean a common factor of 2. And we've already kind of talked about that, why that will never happen. So if these are going to work, it has to be a 3 in the first bracket, a 2 in the second, and these two numbers multiply to get negative 6, so one's going to be positive and one's going to be negative. So that means you could have a positive 3 and a negative 2, or a negative 3 and a positive 2. We'll need to check them both to find out which one works and which one doesn't. So let's check the first option, the positive 3 in the first bracket, that's with the 4x, the negative 2 in the second bracket with the x. So the outer products, 4x times negative 2 is negative 8x. And then it would be positive 3 times 1x, which is positive 3x. Negative 8x plus 3x does give us negative 5x. So that should be the one that works. It should be 4x plus 3 and 1x minus 2. Now the reason why the other one will not work, and we'll do that just to see, the reason why this other one doesn't work. If you did the 4x times the positive 2, that would give you positive 8x. And negative 3 times x is minus 3x. 8x take away 3x is positive 5x, not negative. That's why that other one will not work. There's only one set of factors that will work for these. So we believe we have the correct factors. We're going to check. We're going to check by multiplying them out. So again, you've got the 4x squared at the start that you need. You've got the negative 6 at the end that you need. Negative 8x plus 3x is our minus 5x. So we have just shown that our factors are correct. They actually work. Try this next one on your own, and then we'll check it. So the start should be fairly straightforward because there's only one possibility for those first two terms. You need a 2m in one bracket and an m in the other. There's no other option. The last numbers have to multiply together to get our negative 4. So that's either a 2 times a 2 or a 4 times a 1 or a 1 times a 4. But it won't be 2 times 2. We could not have a 2 in the first bracket because of the 2m as the first term. That won't work. If there was a common factor of 2, it would have been at the start. So really, we only have either 4 times 1 and 1 times 4. And again, for the same reason, you can't have a 4 in the first bracket because there's a common factor of 2 between those two terms. So the only one that might work is if we had a 1 in the first bracket and a 4 in the second bracket. Now, there are two possibilities for that though, because they have to multiply to get a negative 4, which means one of the numbers has to be positive, the other number has to be negative. So there are two possibilities for the last term. Okay, it can either be a positive 1 and a negative 4, or a negative 1 and a positive 4. In both cases, they will multiply to get the last term of negative 4, so that's great, but the outer and inner products will be different. So you'll get a different middle term when you check each of these. So let's start by checking a positive 1 with a 2m, a negative 4 with the m. The outer products would be negative 8m, the inner products would be positive 1m. Negative 8m plus 1m is negative 7m. That's not correct because we need a positive 7m there. So those will not work. We can cross those off. So that means the other ones should work. The 2m times a positive 4 gives us positive 8m. The negative 1 times m is minus 1m. 8m take away 1m is positive 7m. That is the correct middle term. So those should be our factors. 2m minus 1 and m plus 4. But to make sure, we will check. Using the distributive property, we'll multiply these out. So So 2m times m is 2m squared. 2m times 4 is positive 8m. Negative 1 times m is minus 1m. And negative 1 times 4 is minus 4. 8m take away 1m is 7m. That's the right middle term. We've also got the 2m squared at the start that we needed, the minus 4 at the end. We have just shown that these factors are correct. They do work. Now again, we've talked about how important factoring is. It's used quite a bit as you go through high school mathematics. One of the things we use it for is to help us solve certain equations. Another thing that we use it for is simplifying some rational expressions. So those are expressions where you have a numerator and a denominator, and they have polynomials in both. You will learn about simplifying those using factoring. So it's an important skill. So on the next page, remember the first thing you always need to look for is a common factor. And if there is one, you take it out. It's much easier if you do that. And in this case, there's a common factor of 2 that we would take out, which will give us 6x squared minus 11x minus 10. So that common factor of 2 will be one of our factors at the end. We can't forget about it. Remember, factors are things that multiply together to get what you start with. So you take out a common factor of 2, that's going to be one of our factors at the end. But we're not done yet. We need to see if we can factor the 6x squared minus 11x minus 10. And again, we'll do it the same way. So front terms have to multiply to get 6x squared. So what's going to work there, Keaton? I want you to put your phone in your backpack. Thank you. So what's going to work there? Use your man's voice here. Kai, can you give me one possibility for those first terms? 3 what? 3 what? 3 bananas? 3 oranges? 3 x's. So if the front term is 3x, what would have to be the front term in the other bracket? Is 3x times x give you the 6x squared that we need? Yes. So if you put a 3x in the first bracket, you'll have to have a 2x in the other bracket because they multiply to get 6x squared. Is there another possibilities for those front terms, Cherry? That's right. You can also do 6x times x, like she said, which is the same as 1x. Same thing. Now, the last terms have to multiply together to get negative 10. So it can be a 2 and a 5, or a 5 and a 2, a 1 and a 10, or a 10 and a 1. However, because you have and let's first check with 3x and 2x. I said earlier that we always start with the ones that are closest together, right? 3 and 2 are closer together than 6 and 1. And for the last term of negative 10, I would use the 2 and the 5 before I'd use the 1 and the 10. Use the numbers that are closest together. And you wouldn't have a 2 with the 2x for the reason that we've talked about several times already. You would not have a 2x and a 2 because that would mean there's a common factor of 2 there. But if there was, there would have been one that we would have taken out of the 6x squared minus 11x minus 10. So that would mean the 2 would have to go with the 3 and the 5 would have to go with the 2. But because they multiply to get negative 10, there are 2 possibilities even with the 2 and the 5. You could have a positive 2 and a negative 5, or you could have a negative 2 and a positive 5. 2 different scenarios there, and then we multiply them out. We're going to get 2 different middle terms. Remember, we're trying to get a middle term of negative 11x. So, if I did the positive 2 in the first bracket, the negative 5 in the second, the outer products, 3x times negative 5 would be negative 15x. And the inner products would be 2 times 2x, which is positive 4x. Negative 15x plus 4x does give us negative 11x. So we are saying that the factors are, can't forget about the common factor of 2 that we took out to start, then 3x plus 2 and 2x minus 5. That's what we're saying. Now, just to show you that the negative 2 in the first bracket and the positive 5 in the second will not work. Just to show you that. If you were to multiply out with the negative 2 in the first bracket, the positive 5 in the second. So it would be 3x times positive 5, which is positive 15x. Negative 2 times 2x is negative 4x. 15x take away 4x is positive 11x, not negative 11x. So that's why those will not work. There's only ever one set of factors for every polynomial. And to make sure, we will check. And in this case, we would first check by multiplying the 2 by the 3x plus 2. Each term there would get multiplied by the 2 in front. So that'll become 6x plus 4. That is now multiplied by the 2x minus 5, the second binomial. Brody, you with us? How would we do that? You use distributive property. Whenever we have a binomial times a binomial, we've always used distributive property. So 6x times 2x is our 12x squared. 6x times negative 5 is negative 30x. 4 times 2x is positive 8x. And 4 times negative 5 is negative 20. The negative 3x plus 8x is minus 22x. So Cheney, are our factors correct? Are they correct? Did we do it right? How? How do you know? And also the minus 22x. When we multiplied it out, the answer we got matches what's up above. That's how we know our factors are correct. So what I put in the box, those are the factors. Those are the three things that multiply together to get what you start with. So for this next one, again, always look for a common factor first. And there is a common factor between those three terms, a common factor of 3. So to get what's inside the brackets, again, you divide each term by 3. This will give you 10y squared minus 13y minus 3. When you divide all three of those terms by 3, that's how we get what's inside the brackets. So we're going to see if we can factor that trinomial that's inside the brackets. So you're looking for two things that multiply together first to get the 10y squared. What would you try, Brooklyn? 2y and 5y. Is there anything else that we can try if this doesn't work? 10y and 1y. We always start with the numbers that are closer together. So I'm going to start with the 2y and the 5y. Now, the last terms have to multiply together to get that negative 3. So it's either 1 times 3 or 3 times 1. And because they multiply to get negative 3, one of them's got to be positive, one's got to be negative. So if we're going to check all our possibilities, we might try a positive 1 and a negative 3, a negative 3, and a positive 1. Well, actually, let me do this in a more systematic way. Positive 1, negative 3, negative 1, positive 3. So you see in both cases, I've got a 1 in the first bracket and a 3 in the second. But I've switched the signs. And if I can't get these to work, then I'll switch the 1 and the 3's around and put the 3 in the first bracket and the 1 in the second. You don't know until you check. So if I did the positive 1 in the first and negative 3 in the second, 2y times negative 3 is negative 6y, and then 1 times 5y is positive 5y. Negative 6y plus 5y is negative 1y, not negative 13y. So that doesn't work. So what if we did the positive 3 in the second, and the negative 1 in the first? 2y times 3 is positive 6y. Negative 1 times 5y is negative 5y. 6y take away 5y, again, is positive 1y, not negative 13. So neither of those work. And like I said before, if these don't work, we'll switch them around where we have a 3 in the first bracket and a 1 in the second bracket. So let's try that. A 3 in the first, a 1 in the second. The only thing that might change is the sign. So if I put the 1 in the second as negative and the 3 in the first as positive, and if that doesn't work, I'll switch those signs around. So 2y times negative 1 is negative 2y. 3 times 5y is positive 15y. 15y, take away 2y, is positive 13y. So we're almost there. We've got the 13, but we have the wrong sign. So that means the other possibility should be the one that works. If it was 2y times a positive 1 and negative 3 times positive 5y, 2y times 1 is 2y, negative 3 times 5y is negative 15y, 2y take away 15y is negative 13y. So it appears that the correct factors are common factor of 3, then it's 2y take away 3, and 5y plus 1. To make sure, for sure, we will do our check. I'm going to multiply out the brackets here, multiplying the 3 by the 2y take away 3. That'll give us 6y take away 9. That is then multiplied by 5y plus 1. And to multiply those out, again, how do we do that, Declan? Distributive property. Yep. Multiply each by each other. We do that using distributive property. So I'll get the 30y squared that I needed. 6y times 1 is positive 6y. Negative 9 times 5y is negative 45y. And negative 9 times 1 is negative 9. So we've got the 30y squared that we needed at the start. 6y take away 45y is negative 39y. That's the right middle term. And then the minus 9 at the end. So we have just showed that our factors are correct because they do multiply out to get what you started with. All right. So on the next page, there's an assignment there for you to work on. I'm not going to collect this one for marks because I want you to have some practice with it. I'm not going to collect this one for marks, so please don't rip it out. If you ripped it out, go to the office. I'm done. Okay, so this one doesn't have to be collected for marks, but Brock, you need to do it still for practice because the next assignment you are going to hand in for marks. This is the hardest type of factoring you're going to have to do. This is it. This will be the hardest it gets. We're going to look at some other factoring a little bit later that's a little bit easier, but this is the hardest because you have to do all that guessing and checking. So do these for practice. I will put the solutions on Google Classroom so you can check your work, but it's important that you do the practice. Sorry? This is the hardest type of factor you're going to see in this class.
In this class?
In this class.
Oh, I thought it was for the rest of high school.
No, there'll be some stuff a little bit harder later on, but for now, this is the hardest. Yes, ma'am. Yep. Yep, but there's only supposed to be one at a time. So, and I know Princess asked earlier too, so. Yeah, but you obviously forgot about it, so you didn't have to go that bad. Yeah. Yes, you can. Make sure you sign out. One boy, one girl at a time.
Are you sure this is still considered a boy?
And so you can go after Sal comes back, okay?
Wait, I asked first. Wait, I asked first. I forgot about it. Dog.
But you just admitted you didn't even have to go.
Well, now I have to go.
Well, I already told it.
No, I'll just wait for it.
Okay, I was gonna say you can flip a coin to see which you're supposed to go.
Okay.
Want to do that way?
Actually, not. I'm ready to go. Yeah, do I need to go? Me too.
Okay. Henry, heads or tails? Call it in the air.
Tails.
You said tails? What is it? Team?
It's
Heads.
no, it's even.
So Princess gets to go.
That's okay. She can go first.
Well, then why did we even do that thing?
She looks like she's about to. Yeah, actually.
Can you wait 2 minutes?
Yes.
Okay. Yes, ma'am. Of course. You don't have to ask to do that. As long as you're not putting bad words up there or dirty pictures, you don't have to ask.
What?
Because Princess doesn't like that sort of thing. You were supposed to come and see me to do this, finish this off. So you can do that now. Also, guys, don't forget that you're checking Google Classroom and PowerSchool. If you got assignments that are due that you haven't handed in, that'll be on PowerSchool.
Why are you blushing so much? Why? Please. Just don't drink enough water. He doesn't go here. I'm talking about the other two. I'm talking about the other one. What? The hell? No. Oh, no. I look like I look like no.
Keen, come on in.
I can't even see him. Why do you look like that? I literally just said, I'm gonna stain this cookie, bro. How's Ian back? No. Don't do it. Did you get your child? What child?
Keen, come on in.
Bro's adopted.
You got work to do.
Are you in the He is such a bully.
Yep.
Imagine
Imagine
walking.
walking. Imagine not getting picked up. I'm joking, no car. There's no car today, guys. Next time, you can drive. Maybe tomorrow.
All right, guys, you got those questions to do. Sit down and get to work. Keen?
You actually go get your garbage. Did you see Jerry's story? I'm gonna I know.
Is this page 63 in your package?
Yes. No. Not like, as in like, how do I? No, because mine is just like my hair looks like no. So I look at you. Oh yeah.
Miss you, man.
No, I thought you were crush your booking. Voice is like deep. I didn't expect it. Isn't it? I didn't expect it to be like. Hi. Oh, why not?
Keen, sit down and get to work.
No.
It's kind of high.
What grade is he? Grade 8.